Okay, hello everyone in a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body and Archimedes upthrust. This exercise was a previous one in the Breve exams in 2018 first session, exercise number 2. The title of this exercise is Nature of a Liquid. The aim of this exercise is to identify the nature of a liquid L. For this, we consider a container that contains a certain quantity of L and a solid S of volume V is equal to 5 times 10 to the power minus 5 meter cube. The volume of this solid is given by V is equal to 5. Okay, so here the volume is in the SI, the unit. So meter cube is the SI unit of volume. Suspended to the free end of spring balance, take G is equal to 10 newtons per kilogram. Number 1. So S is at equilibrium in air, document 2. So they mentioned document 2, then now we can use it. Notice that till this moment they didn't mention anything about document 3, so we are not allowed to use it. The spring balance indicate 3.9 newtons. So the spring balance in document 2 indicates 3.9 newtons. So knowing that Newton is the unit of a force, in particular the weight. So what does this indication represent? So here, because the solid S is suspended from the spring balance at equilibrium and in air, then the spring balance indicate its real weight. Then let's say, since the suspended object is in air, at equilibrium, then the spring balance indicates its real weight. Then in this case, the real weight is given by 3.9 newtons. So this is R for real. And now in number 2, S is completely immersed in L of density rho, document 3. So they mentioned document 3, then now we can use it. So here S is completely immersed in L, this is important. So here, as we can notice that S is completely immersed in L, and the spring balance then indicates 3.5 newtons. So previously, when the solid S was attached to the spring at equilibrium in air, the spring balance indicates 3.9 newtons. When the solid S is immersed in L, the indication of the spring balance changed to 3.5 newtons. Now 2.1. What does the indication of the spring balance represent in this case? So knowing that the solid S is immersed in liquid and it is at equilibrium, then in this case the spring balance indicates its apparent weight. Then let's say, since the suspended object is immersed in a liquid at equilibrium, then the spring balance indicate its apparent weight. Therefore, the apparent weight is given by the indication of the spring balance, which is given by 3.5 newtons. So here let me write that the real weight of the object is given by 3.9 newtons, whereas its apparent weight is given by 3.5 newtons. Now in 2.2, give the name of the force that led to a different indication on the spring balance. So here, because we have a liquid, then the solid S will be directly subjected to Archimedes upthrust force, F upthrust. Then the name of this force is Archimedes upthrust force, which is denoted by F vector upthrust. Now 2.3, calculate the magnitude of this force. Let me make some space. Now here, because we have the value of the real weight and the value of the apparent weight, then we can directly determine the magnitude of this force, because it's the difference between the real weight and the apparent weight. Now the value of the real weight is given by 3.9 and the value of the apparent weight is given by 3.5. Now plugging this on the calculator, it will give me 0.4. Since both the real weight and the apparent weight are in newtons, so the value of F upthrust will be in newtons. So F upthrust 0.4 in newtons. Then in this case, what does F upthrust, this value, represent? It represents the magnitude of the force vector F upthrust, so which is the fourth property from the building. Now in 2.4, deduce the density rho of L. Here notice that rho represents the density of the liquid L in which the solid S is being immersed. And the word deduce means that we need to use the part just previously before. In part 2.3, we have determined the value of F upthrust, which is given by 0.4 in newtons. And we know that the density of the liquid and the value of F upthrust are related via the following formula. F upthrust is equal to the density of the liquid multiplied by the volume of the immersed part of the object multiplied by G, in which G represents the value of the gravitational field strength, which is equal to 10 newtons per kilogram. Knowing that we are interested in calculating the value of rho, then constructing the triangle of this formula. Here, because we have multiply, then F upthrust will be at the top, rho, Vi and G will be at the bottom. Knowing that we are interested in calculating the value of rho, then putting our hand over rho, which is the density of the liquid, it will be given by F upthrust divided by Vi multiplied by G. Now here Vi represents the volume of the immersed part of the object, but here, because the solid S is completely immersed in the liquid, then Vi, so the solid S is completely immersed in the liquid, then Vi will be equal to the volume of the object, which is given here to be 5 times 10 to the power minus 5 meter cube. So here, let's write between the brackets, since S is completely immersed in L, then Vi is equal to V. So this statement is very important. They usually give a half a mark for this statement. Now rho in this case will be given by F upthrust divided by V, because Vi now it's equal to V. So we have replaced Vi by V multiplied by G. Now the value of F upthrust is given by 0.4. The value of V here from the given is given by 5 times 10 to the power minus 5 in the SI. And the value of G is given by 10, which means that we are performing this experiment on Earth. Now plugging this fraction on the calculator, it will give me 800. Since F upthrust, V and G are in the SI, so the value of rho will be in the SI, which is kilogram per meter cube. Then the value of the density of the liquid is given by 800 kilogram per meter cube. Now finally in part 2.5, By referring to the table below, deduce the nature of L, and the word deduce means that we need to use the part just previously before. In part 2.4 we have determined the density rho of the liquid, and here in the table we have the densities of different liquids. Then comparing the value of rho to these values, we can notice that the used liquid is alcohol. Then let's say, since the density of the liquid L is equal to the density of alcohol, then the liquid L is alcohol. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.